Lanczos resampling and Lanczos filtering are two applications of a mathematical formula. It can be used as a low-pass filter or used to smoothly interpolate the value of a digital signal between its samples. In the latter case, it maps each sample of the given signal to a translated and scaled copy of the Lanczos kernel, which is a sinc function windowed by the central lobe of a second, longer, sinc function. The sum of these translated and scaled kernels is then evaluated at the desired points. Lanczos resampling is typically used to increase the sampling rate of a digital signal, or to shift it by a fraction of the sampling interval. It is often used also for multivariate interpolation, for example to resize or rotate a digital image. It has been considered the best compromise among several simple filters for this purpose. The filter is named after its inventor, Cornelius Lanczos. Definition: Lanczos kernel equals. The effect of each input sample on the interpolated values is defined by the filter's reconstruction kernel L, X, called the Lanczos kernel. It is the normalized sinc function sinc, X, windowed by the Lanczos window, or sinc window, which is the central lobe of a horizontally stretched sinc function sinc, XA. For A per mole currency XA per mole currency A. Equivalently, the parameter A is a positive integer, typically 2 or 3, which determines the size of the kernel. The Lanczos kernel has two AA1 lobes, a positive one at the center and AA1 alternating negative and positive lobes on each side. Interpolation formula equals, given a one-dimensional signal with sample C, for integer values of I, the value s, x, interpolated at an arbitrary real argument x is obtained by the discrete convolution of those samples with the Lanczos kernel. Namely, where a is the filter size parameter and is the floor function. The bounds of this sum are such that the kernel is zero outside of them. Properties: as long as the parameter a is a positive integer, the Lanczos kernel is continuous everywhere, and its derivative is defined and continuous everywhere. Therefore, the reconstructed signal s, x, 2 will be continuous, with continuous derivative. The Lanczos kernel is 0 at every integer argument x, except at x equals 0, where it has value 1. Therefore, the reconstructed signal exactly interpolates the given samples. We will have s, x, equals c for every integer argument x equals I. Multidimensional interpolation. Lanczos filter's kernel in 2 dimensions is simply the product of two one-dimensional kernels. Given a 2-dimensional signal sig defined at integer points of the plane, the reconstructed function is. When resampling a 2-dimensional signal at regularly spaced points, one can save some computation by resampling the entire signal along a single axis, then resampling the resulting 2-dimensional signal along the other axis. These formulas generalize to signals with 3 or more dimensions, in the obvious way. Evaluation. Advantages equals. The theoretically optimal reconstruction filter for band-limited signals is the sinc filter, which has infinite support. The Lanczos filter is one of many practical approximations of the sinc filter. Each interpolated value is the weighted sum of 2 consecutive input samples. Thus, by varying the 2 parameter, one may trade computation speed for improved frequency response. The parameter also allows one to choose between a smoother interpolation or a preservation of sharp transients in the data. For image processing, the trade-off is between the reduction of aliasing artifacts and the preservation of sharp edges. Also, as with any such processing, there are no results for the borders of the image. Increasing the length of the kernel increases the cropping of the edges of the image. The Lanczos filter has been compared with other interpolation methods for discrete signals, particularly other windowed versions of the sinc filter. Turkowski and Gabriel claimed that the Lanczos filter the best compromise in terms of reduction of aliasing, sharpness, and minimal ringing, compared with truncated sinc and the Bartlett, cosine, and Han-windowed sinc, for decimation and interpolation of 2-dimensional image data. According to Jim Blinn, the Lanczos kernel keeps low frequencies and rejects high frequencies better than any filter we've seen so far. Lanczos interpolation is a popular filter for upscaling videos in various media utilities, such as RV-synth and FFmpeg. Limitations since the kernel assumes negative values for a greater than 1, the interpolated signal can be negative even if all samples are positive. More generally, the range of values of the interpolated signal may be wider than the range spanned by the discrete sample values. In particular, there may be ringing artifacts just before and after abrupt changes in the sample values, which may lead to clipping artifacts. However, these effects are reduced compared to the sinc filter. For A equals 2, the ringing is